Hi everyone, good morning. Now from today onwards we will have complex property topics, that is magnetic behavior. What are the types of magnetic behaviors? We'll show the complexes and their properties such as magnetic moment, magnetic susceptibility, like this we will going to discuss, and where the magnetic moment will help you to uh, find out the complex characters. That's how the part of magnetic behavior in bonding elemental complexes will follows, right? Let us start the first topic, that is types of magnetic behavior. Before going for the types of magnetic behavior, here we have to understand that what is actually magnetic behavior, what is the magnetism, right? How it is arises, that initially we have to know, right? To have a discussion of this, we have to know that Bohr's atomic model, right? And how the electrons are arranged, how it is in the atom, that we have to know, right? We know that there is atom will have a nucleus centrally situated, and around it there are multiple orbitals where it has multiple number of electrons, right? The diagram may not be exactly atomic structure, but overall that was the atomic structure, spherical structure as per the Bohr, situated the nucleus situated, etc., and surrounding it there are multiple number of orbitals which carries the electrons, right? And here the electron is the active one to define or to raise the magnetic property in the molecules or in the substances, right? So the electron is the moving body in the atom, and it has the two motions, right? We know that it has a two motions. One is circular motion, right? Electron will revolve around the nucleus in a circular pathway, that is the one motion, right? And other motion it has, that is spinning, right? Electron it himself revolves and thus is considered to be as spinning, right? Electron will have rotation motion around the nucleus, and it has spin motions along it himself, along its own axis, right? These two motions will have two uh, characters or two belongings, right? There, when it is revolving or spinning, is nothing but it doing some work, right? Electron, when it is having participating in motion, it it generates some energy, right? As it is revolving around the nucleus, there certain energy will generate, and as it is revolving it himself, right, spinning it himself, that also generates some energy, right? And when it is revolving around the nucleus, right, generated energy and its reflecting property or respective represented property can be called as orbital angular momentum. Orbital angular momentum, right? The motion will be called as orbital angular momentum, and it's reflected or represented with mu l. And electron, as it is spinning around it himself, and it would be represented with spin angular momentum. Spin angular momentum represented with mu s, right? and these two cannot be separated from one to other, since it is uh, shown by the single particle, right? It's shown by one particle electron, right? And it cannot be uh, separated from one to other. So these two together contributes the momentum, magnetic momentum in the atom. From the atom, it reflects into the molecules. From the molecules, gets through the gets to the substances, right? When we have to discuss the magnetic behavior of these substances, we have to inner deeply we have to go through, right? So substances are made up of molecules, molecules are made up of atoms, right? Atom will have certainly some primary particles, where the one of the primary particle of electron will having the motions of certain orbital angular momentum and spin angular momentum, and their contributing magnetic momentum will gets the magnetic behavior in the atom, from that molecule, from that substance, right? So now you got that how does the why does the substances will have magnetic behavior due to these two, right? We know that the magnet, when we are placed in another magnetic field, right, in place of another magnet, if you are placing if you are placing one magnet in place of another magnet, there certain interactions will take place, right? This is the magnet. If we are taking and placed in another magnet, around another magnet, what happens? They certainly will have interactions, right? Either they repel or attract, either they repel or nor attract. They either repel they or attract. Similar to that, when a substance placed in an external magnetic field, right? When you are placing a compound in an external magnetic field, right? Certainly these substances also has either they has the certain interaction, they will have interaction, the substance will have interactions. Based upon the substance's interaction, right, with the external magnetic field, the substances are classified into two types, right? Broadly classified into two types, that we can say that initially magnetically dilute compounds, dilute substances, and magnetically concentrate substances. Like this, we will have two different broad classification of substances with respect of magnetic behavior, or we can say that the substance interaction with external magnetic field, right? The magnetic dilute substances, right, or that the substances which have the individual uh, magnetic centers, right? The substance what I said, right, it is made up of molecule, and molecule is made up of atom, like that I said, no? There the atom is the individual magnetic center, or inner dipole if you go, electron is the magnetic center, right? Let us consider that atom or molecule is the individual uh, magnetic center. Thus, in the substance, there are multiple magnetic centers, right? Individual magnetic centers. Thus, individual magnetic centers, when they are arranged in manner that they are not cannot be they cannot be interact with each other, right? Take consider that this is what the substance, right? May not be exactly like this. The substance may not be like this, but let consider that, right? And in which there are certain individual magnetic centers, right? And thus individual centers, if they are not they are positioned or placed in a manner that they cannot interact with each other, then thus type of substances will be called as magnetically dilute substances, right? Now you got, right, when there are individual centers in a magnetic substance, if they are not interacting with one another, then that would be magnetically dilute substance. Here the magnetic behavior comes that in this magnetically dilute substances, that is paramagnetism or paramagnetic substances and diamagnetic substances. These two are belongings to magnetically dilute substances, where in this the individual magnetic centers cannot be interact one another, so that the theoretical and practical magnetic moment values are nearly equal, right? Nearly equal in this para and diamagnetic moments, right? Magnetic substances. And most common magnetism or magnetic behaviors of substances in complexes is these two, right? The complexes either para or dia most of the time, right? So the common, we can give a statement that the common magnetism in complexes is para or diamagnetism, right? That's how the magnetically dilute substances, right? The second class of substances, right, are magnetically concentrated, reverse to the magnetically dilute substances, right? There was nothing but how we defined it, the magnetic dilute substances. We said that magnetically dilute substances are has the individual magnetic centers are away from one to other, right? Here they will be closer and they can interact one to other, right? Like that. Magnetically concentrated substances. The compounds having individual magnetic centers as they can interact each other will known as magnetically concentrated compounds. Substances are compounds, right? So here the magnetic behaviors are ferromagnetism, antiferro, ferrimagnetism, right? These will come. One more point I left in the last topic, magnetically dilute substances. The paramagnetism and diamagnetism is generated with respect of unpaired electrons in the substance. Para or diamagnetism is depends on unpaired electron density of substance or compound. Whereas the ferro-antiferro-ferrimagnetism is actually generated due to the lattice defects in the crystal, or generated due to lattice defects in crystal substances, right? Like this, the magnetically dilute substances and concentrated substances can be expressed, right? Now let us discuss the common magnetic behaviors in the complexes, that is para and dia. This part of paramagnetism, diamagnetism is maybe known to you from the B.Sc knowledge. Let again repeat and let extend somehow the unknown parameters or unknown characters of the para and diamagnetic substances. The substance in definition of diamagnetic substances, the substance in external magnetic field in vacuum repelled by external magnetic field called as diamagnetic substance, and the character called as diamagnetism, right? This is known to you, but why it happens like that? Why the diamagnetic substances should repel by the magnetic external magnetic field is uh, maybe unknown, or some may known, but exact thing I will express here. Why it happens? The diamagnetic substances are repelled by the external magnetic field. Let us take a substance, diamagnetic substance, placed in an external magnetic field, right? So as it is external magnetic field, there is magnetic waves will be generated, right? Considering a diamagnetic substance in a external magnetic field, right, get repulse. Why it is repulsing? Right, initially what happens is that external magnetic field will starts to flow from one end to other end. Its waves are starts to flow from one end to other end, right? These waves, after getting towards the after moving towards the diamagnetic field, this will be restricts its flow from one end to other end. Why this is happens? That diamagnetic substance will have the magnetic moment value is 0. As it is having magnetic moment value is 0, the diamagnetic substances never allow the external magnetic waves to flow from them, right? From innerly it cannot, it restricts the flow the magnetic waves by the diamagnetic substance. So far, as it is restricting, the diamagnetic substance is restricting the flow of magnetic waves from one end to other end. These waves will pull the hindering diamagnetic substance to get away from the flow from the one end to other end. But that's why the diamagnetic substances are uh, expressed or projected as that they are repelled by the external magnetic, right? This is what happens with the diamagnetic substances, right? So now let we know that why the mu is becoming zero, right? Now you got that why the diamagnetic substances are repelled by the external magnetic field. Now let us know the diamagnetic substances, why diamagnetic substances will have mu is equal to 0. We know that I told you that diamagnetism and paramagnetism is depends upon the unpaired electron density in the substances, right? So here the diamagnetic substances will have zero number of unpaired electrons, which means that all the electron density in the diamagnetic substances will be paired form, right? Will be in paired. So the diamagnetic substances or compounds will have paired configuration, paired electronic configuration, since which nothing but in an one orbital all the orbitals are fully filled, nothing but each orbital will consist two electrons, right? With this two electrons, what happens is that as they are showing, one is upward and another is downward, this labeling of showing of electron will have their significant role, right? Their momentum value, right? Why they has to show this, one is upward, one is downward, or one is clockwise and another anti-clockwise, is due to their magnetic moment value, right? The electron having all same characters one to other, they all carry same amount of magnetic moment, right? But as their flow pathway is one to other reverse, right? Some will be have positive magnetism, some will have negative magnetism, right? One to other they will have positive negative magnetism, right? So here, as in the one orbital having paired electrons, one will, if it is having positive magnetic value, the other will be have same amount of negative magnetic moment value altogether, right? In a diamagnetic substance altogether, the magnetic net moment value will become 0. To have net value, we have to add together, right? Linearly we have to add together. When we add all the electrons magnetic moment, as there are some having positive magnetism and same equal number of electrons will have equal negative amount of magnetic moment, will add together, will result of net momentum value is 0, right? That's how the diamagnetic substances will have the magnetic moment value is 0, right? By as they are possessing the paired electron configuration, this is what happens, right? And this diamagnetism character is individual of temperature, independent of temperature. It is not dependent, right? with respect of temperature, it never be going to change its behavior or its amount, right? And diamagnetic substances have lower induced magnetic field than uh, applied magnetic field. In the external magnetic field, it diamagnetic substances will induce its magnetism, right? Thus, induced magnetism will be always lower than external magnetic field. Here, B is induced nothing but uh, on the substance generated magnetic field. H is external magnetic field, right? Where in the diamagnetic substances, this induced magnetic field of diamagnetic substances will be almost every time will be lesser than external magnetic field, and the permeability of diamagnetic substances always lesser than one number, right? And the diamagnetic substances magnetic susceptibility magnetic susceptibility will always negative, will have all negative values. This is negative values. That's how the diamagnetic substances and their characters we can represent, right? Let us now discuss the paramagnetic substances, right? The substance, this paramagnetism, diamagnetism, you know that they are one to other reverse characters, right? Opposite characters. So diamagnetic substances, as they are repelled by the external magnetic field, when we define the paramagnetism, they will be attract, the character is reverse, right? The substance in external magnetic field attracted by external field called as paramagnetic substance, right? The behavior will be called as paramagnetism. Right, paramagnetism, that's how. And this particular paramagnetic substances will attracted by the external magnetic field. Why it is happening? Let us see. Considering a paramagnetic substance in an external magnetic field, right? Initially, the external magnetic field starts flow its way from one end to other end, where the paramagnetic substance having magnetic moment value will allows the magnetic waves to flow from them, from the substance. It allows the magnetic waves are allows to flow, right? There, as it is allowed, right? Then what happens? This would be attracted by the external magnetic field, right? This would be attracts the external magnetic field. That's how the paramagnetic substances will be attracted by the external magnetic field. Diamagnetic substances are repelled by the external magnetic field, right? Why the magnetic moment not equal to zero? Because paramagnetic substances always have unpaired electrons, electron density, right? The unpaired numbers may be 1 or more than 1, any number, right? So having thus unpaired electrons, it net moment value will never be 0. It net magnetic moment value never be cancelled by one to other, right? What are the paired amount of electrons magnetic moment will be there, that will be cancelled, but net as it is having unpaired electron, right, which nothing but there will be certainly at least one orbital which consisting only one electron will be there, right? At least one orbital will have single electron in it, right? There this will counts for the its magnetic moment, and this will result into the magnetic moment value which is not equal to 0, right? Diamagnetic paramagnetic substances is temperature dependence. Paramagnetism is temperature dependent, right? With respect of temperature will have different values, will affects the temperature. Lower higher temperature will changes the paramagnetic value, magnetic moment value. And here induced magnetic field will be greater than external magnetic field, right? As the flow of magnetic waves are along the substances, its induced magnetic field will be more, right? That is what the difference from diamagnetic to paramagnetic. And the permeability of paramagnetic substance also greater than 1. It has the value permeability value is greater than 1, it consists. And the susceptibility will always positive. It has positive susceptibility values, right? So like this, the para and diamagnetic parameters we can express in complexes. So here I stop today's online class regarding magnetic properties in the complexes. By next we will going to have magnetic susceptibility and its practical experiment such as Gauss method to describe the susceptibility in practically. Okay, right, thank you.